Hello students, and welcome you all again to this video lecture series on introduction to powder metallurgy. In last lecture we have seen, or we have started the actual applications of powder metallurgy. In that we have started the first application, that is a self-lubricated bearing. In that lecture we have seen what is the working of self-lubricated bearing, what are the characteristics of that self-lubricated bearing, and what are the applications of that self-lubricated bearing. After that, we have seen the flow chart of the self-lubricating bearing by powder metallurgy. There we need 6 steps to prepare that. First step is making the powder of the metals. Second step, mixing and blending. Third step, compaction. Fourth step, sintering. Fifth step, secondary machining operations, and last 6 step, that is testing and inspection. Then your final component, that is a self-lubricated bearing, will be finally produced. But this is the steps for powder metallurgy. Just one small addition and in detail flowchart for the self-lubricated bearing by powder metallurgy is as shown in this figure. So firstly, the powder of copper and tin is prepared. So first step is preparation of powder, and here for self-lubricated bearing we are using the powder of copper and zinc. The component is produced by making the alloy of copper and tin. So copper and tin in proportion 90:10, as well as a small amount of natural graphite is added, and then in second step those are mixed together thoroughly. In third step, they are cold compacted at the pressure 275 to 480 megapascal. After that, next is sintering process. So here also sintering process is carried out by the two ways, in reduction atmosphere, or the temperature in between 400 to 450, and at the temperature above or at the 800 degrees Celsius. So at these two temperatures, these whatever cold compacted components are there, those are processed, and they are then, after sintering, they are sent to the repressing or machining. After those repressing and machining, these are oil impregnated with the cold or hot oil, and after oil impregnation, uh, your component is prepared. You have to do the testing and inspection of that component, and after good testing and good inspection results, these final application, that is a self lubricated bearing, will be prepared. So this is the flow chart. Through this flow chart we need to go step by step. So in exam you need to draw this flow chart and explain each step in detail. So we will see all the steps. In first step in that flow chart, you need to prepare the powder. Now for manufacturing the self-lubricated bearing, we are using the copper, tin and graphite in the proportion 90 as to 9 as to 1. So copper in proportion 90%, tin in 9% and graphite as 1%. In that flow chart I have shown copper and tin as a 90 as to 10% and small amount of graphite. That graphite is actually in 1% as compared to total 100%, so that proportion will become a 90 as to 9 as to 1. So how to prepare that powder of copper and tin? For that purpose, copper powder is prepared by electrolysis process, electrolytic deposition, and tin powder is prepared either by electrolytic deposition or atomization process. So what are these processes that we have seen in previous videos? How to prepare the powder by electrical process, and how to prepare by powder by mechanical process and by atomization process. So electrolytic deposition process is as shown in that diagram. Here you have to use the negative cathode electrode and positive anode electrode, and in that you are using one solution. That solution, or it is called as a electrolytic solution. That electrolytic solution is of copper sulfate. If that copper sulfate is passed through the, or through that copper sulfate solution electric current is passed, then the negative ions of SO4 as well as OH will be attracted towards the anode, that is positive rod, and there they will form small particles of sulfur, and copper positive ions will be deposited on the cathode rod, because copper are having positive ions and these are deposited on the negative rod. So there at the cathode you will get the powder of copper. So similarly, powder of tin also you can get by electrolysis deposition. So these two powders are prepared and the natural graphite is taken. So these three are the powders which are required for production of the self-lubricated bearing. So here anode, in that copper production process, anode used is a crude copper or pure copper, then cathode used is finished aluminum plate, and electrolyte used is copper sulfate. So through this electrolysis process, electrolytic deposition process, you will get the powder of copper and tin. In second step, those powders are mixed thoroughly, and in those two powders one more component, that is graphite 1% is mixed. Graphite is added to improve the porosity and pressing characteristics. Important sentence, because in general the graphite is used in every powder metallurgy component for improving the porosity as well as improving the pressing characteristics. So whatever component is produced by powder metallurgy, there you will find this graphite as a 1%. So mixing properly is done in second step of the three components, that is the copper, tin and graphite. In third step, compaction of the powder takes place. So whatever produced powder is there, it is poured into the molds. In that mold, high pressure, nearly compaction pressure nearly 275 megapascal to 480 megapascal is applied, and then the compacts are obtained, and whatever compacts or components are obtained after compaction, those are called as green compacts. So it includes the densification of powder particles. After compaction you will get the component called as green compact, because they are not strongly densed, they are not strong or final component, that's why they are called as green compact. And small amount of density we are increasing, because the particles will get more and more closer, that's why it includes densification of powder particle. No heating process is there, that's why it is called as a cold compaction. Then for compaction, automated compaction presses are used, or die compaction are used. This process involves three stages as shown in this diagram. First is a powder filling, second applying the pressure, and third is ejection of component from the die. So through these three stages we will get a green compact. So to that green compact, next fourth step we are doing, that is a sintering. So it includes the consolidation of the green compact under the controlled condition of temperature and time. So we are passing this green compact through the few stages. So these stages we will show in the next diagram. So here in the diagram you can observe the schematic diagram of continuous type of sintering furnace. In this furnace, first phase or first chamber is preheat zone. Second is a heating element or heating zone, where the actual temperature is increased just below recrystallization temperature, and in last zone it is a cooling zone. So through these three zones your compound is passed, green compact is passed. First preheat zone, second heating zone, and third cooling zone. So this is called as a continuous type of sintering furnace. So in sintering, for this self lubricated bearing, we are using continuous mesh belt furnace for the sintering. Atmosphere, there hydrogen gas atmosphere is placed, because whatever components are produced, they are heated, and those metals may get react with the oxygen, and there may be oxidation process. We have to avoid that oxidation process, that's why atmosphere kept is of hydrogen gas atmosphere. Sintering type, the liquid phase sintering, we have seen the three types of sintering in previous videos. So from that solid liquid we are using the liquid phase sintering. Next, it is done in the three stages, just we have seen in that flow chart also. three stages we are using. First one is a burn off zone or preheat zone. There we are heating your green compact to the 400 degrees Celsius to 450 degrees Celsius, which is also called as a preheat zone. In that diagram you can observe the preheat zone. Then second zone is a sintering zone where we are increasing its temperature to 800 to 850 degrees Celsius. Here the actual recrystallization will take place, actual bonding between the particles will take place. In first burn off zone, just suppose a raw particles or any other particles contamination, if they are there, they will get eliminated or burnt off at the 400 degree or 450 degree Celsius. In second step, actual bonding takes place in sintering zone, and in third step the cooling will take place in the cooling zone. So through these three processes, sintering is done in the continuous type of sintering furnace. Next, fifth, post sintering operations, that is also called as a secondary operations, such as a sizing and impregnation. What is sizing, what is impregnation, that also we have seen in the first few videos of this chapter. Again I will tell you, in sizing we are controlling the dimensions of bearing within the tolerance. One master die is taken, and on that master die, that sintered bearing is kept, again that is pressurized by small pressure, so that it will again get the exact size of master die, and you will get the final component with the precise dimensions. And that is done by forcing the small part into the die of a smaller dimension and forces. So that is done in sizing. Next, impregnation. It refers to the filling of the pores in the part with the oil. So impregnation is nothing but a filling of the pores in that bearing with the oil. For that purpose, that bearing is put into the jar which contains the oil, so that that oil will get soaked by that bearing, and all the pores will get filled by the oil. The technique used is a combination of vacuum and pressure also. So it involves sintered part placed in the basket and subjected to vacuum, so that the oil is introduced and external pressure of 4 to 5 atmosphere is applied. The pressure is brought to 1 atmosphere and excess of oil is drained out. So at that pressure and at that vacuum, that oil will get filled into the pores of that bearing. That is the process called as impregnation, oil impregnation. The oil is used as a synthetic hydrocarbon and silicon oil generally. So after this fifth step of secondary operation, last step is also there, that is called as testing and inspection. So in the testing and inspection step, you need to test that bearing for various parameters, and you need to check that bearing for any defect, that is called as inspection. After that testing and inspection, your final self lubricated bearing will get prepared. So these are the steps, and this is the flow chart of your self lubricated bearing by powder metallurgy. So study this, and in next video we will have another application and its flow chart to prepare by powder metallurgy method. So thanks for watching.